of St. Peter's College, Nigam branch, for grade 11 ICT third lesson. Last week we discussed about the system development life cycle. That is your second chapter. It is we discussed the part of that lesson. That means stages of the system development life cycle. Today's lesson we discuss about the system development life cycle modules. Before that, I go through the last week slides briefly to revise your knowledge. Right. There are 6 stages. These are the 6 stages: identification of requirements, designing the solutions, coding the solution, testing and debugging, deployment and maintenance of the system. These are the basic 6 stages of the system development life cycle. Each system we do separate set of things and to implement our software. Right. Using these 6 stages, we can model our software in many different ways. Today's lesson, we discuss about those models. Basically, you have to know about 4 models. There are so many models, but you have to learn about these 4 models. What are those 4 models? We will discuss now, and each model characteristics, advantages and the disadvantages like this. Right. These are the 4 modules. First one, waterfall module. It's very basic one. Iterative incremental module, prototype module, and the spiral module. Last week, I previously told us, last week we discussed about the 6 stages of the life cycle. These are the 4 modules of a software developing. Don't confuse those two. Those two are 2 different. Most of the students confuse those two when you are asking the question stages. You have to write the stages of the system development life cycle. These are actually a module, and how to using those 6 stages, how you can model your software. Right, we'll see one by one. First, a waterfall module. Linear development, and then complete the one stage before going to the next stages. In the stages, we learn about the 6 stages: identification and deployment, testing. Likewise, we learn about 6 stages. In this waterfall model, before come to that point, I think you all see the waterfall. It is top-down approach. Waterfalls are falling from top to bottom, right? Water is falling from top to bottom. Likewise, in waterfall model, we discuss about the 6 stages, one by one stage. Once the first initial stage is completed, then you come to the next stage. If you are not complete your previous stage, you can't come to the next stage, right? That's why it's complete the one stage before come to the next stage. Linear development. It's like climbing a staircase or mountain. Linear stage, right? Linear wise. Simple and easy to understand. Very easy. It is very simple and very easy to understand. It is easy to manage. Management process. Management wise also it's easy. Traces are not overlapped, complete one at a time. Here, traces are not overlapping means once you start the information testing, once you're doing the testing the system, you will not do any other things. You just testing your system, and once you complete your testing, you can go to the next stage. Before you go to the next stage, definitely you must complete your previous stage. good for, and it is good for it's good for small projects, not large projects. It's very good. It is not advised to use a large project, this type of models, because sometimes you may get a lot of difficulties in large project if you use a waterfall model. We'll see disadvantage. In testing stage, very difficult to go back to and do the changes. I told you once I discussed the advantages, when you are doing the testing stage, you test your software and you identify any errors and any mistake previous stage. You can't go back to that and do the corrections because it's a top-down approach. You can't go back your stages as other modules. Not good for complex and object-oriented projects, and poor model for long and ongoing projects. Yes. If your project is taking more time, it is not good for this type of selecting, not good for selecting this type of software development model. It is another thing, it is not good for long projects, ongoing projects. That means once you are doing your project while they are running the system, it is not good to advise, not good for use this waterfall model. The thing is, why it is not good for ongoing projects? You can't do this. You can't do both activities at once: developing and testing, and developing and implementing. You can't do that in this model. Once you complete your previous model, then previous stage, then you come to the next stage. That's why it's not good, and it is good for very small projects. That means very simple projects. Like here, the hierarchy is given: system engineering, analysis, designs, code, testing, and the maintenance. This is for waterfall module. Then the second type is second module is the iterative incremental module. What's that? Iterative incremental module. Develop the system through the repeated cycles. It develop the system using many number of cycles. In waterfall module, there is no cycle. Your project is coming from top to bottom, not recycling. That means not a cycle. In here, iterative incremental module, your system is coming so many cycles. Once you complete your one cycle, then your software, one part is over. The second cycle means another part. That's why it's repeated in so many cycles. To complete your project, you must complete so many cycles in your software development. More than one iterating of the software development cycle may be progress at the same time. Another thing, you can't wait for completing one cycle to start the other cycle. You can do the many cycles at the same time. Take an example. In a library system, you can do a cycle as two separate cycles as entering a new member to a library and submitting returning a book or borrowing a book, something like that. You can do many cycles at the same time. Here, in initial planning is there in your system. Initial planning require meeting, planning, analyze and designing, implementation, development, and testing and evaluating. Once you complete your one cycle, you can evaluate your system and submit to the customer and do the necessary things. And while not in waterfall module, whole system and whole software will come as one part. But in iterative incremental module, in your system, that means software, part by part, you can introduce the customer, and customer will customer will adapt to that system. In waterfall model, whole system comes at once. You have to wait in waterfall model, you have to wait to complete whole system. In iterative incremental model, no need for waiting. That complete the whole system part by part. You can implement your system. Advantages: some working functionalities can be developed quickly and clearly in the life cycle. That means functions are very clear, because you will take a small part of the project and do that as a cycle, then go to the next part. You have to gather or think that a small part of your project, then the other part. Results are obtained early and rapidly. That's why I told you, once your cycle is completed, you can submit to the customer, and customer will see the result. In waterfall model, customer has to wait the final product, not in in iterative increment. Parallel development can be done. I told you so many number of cycles you can develop at the same time. That means a group of team may be developing the membership. The other group will be developing the borrowing. The other team can develop the submitting. Likewise, many number of parallel development can be planned, and the progress can be measured. Your project progress, once you complete your membership part, then you will have a progress. Now my progress part is complete. That where your project is now, and less costly to charge the scope of the requirement. Another thing, what's that? Less costly to change the scope of the requirements. That means your cost is little bit low than the waterfall model. Not bit, little bit more lower than the waterfall model. Testing and debugging during the small iterations is easy. You can, example, your whole system will be testing is a separate thing, and your system part will be tested is another separate thing. That you can think which one is easier. From the total system, small part is testing is very easy. You have to consider little area and consider the small piece of software part and testing. Once you complete it, it is easy. You can easily done it. But the waterfall module, that means your whole system will be testing at once. It is very difficult. Risks are identified and resolved during the iterations, and each iteration is an easily managed milestone. That means your task is you have to consider small part of your project software. You have to achieve that target, not the whole part. That means your risk is also low and problems are very low, and identification of those problems and solving those problems is very easy. Easy to manage the risk. High risk parts is done first in your projects. When you are doing your project, you can identify which part is high risk. You can take it as a part and do it separately. Which area is high risk? Low risk areas can be do it separately. And then your risk management is very easily done. With every increment, operational product is delivered. Once you complete your one cycle, you will have a product. That means you will have an output that you can show the customer or the others. Disadvantages: more resources may be required. To work with that iterative incremental model, you need a big workforce. That means your team must be many number of software developers and the programmers. Not suitable for small projects. We are not using these type of systems. or software development models for small projects. We will apply those type of models in bigger projects, not in small projects. Management complexity is more. Manage your each team is very complex. Top level managers has to think which part be how to separate these parts, how to separate the cycles, because sometimes there may be the dependency of each other systems. That means you have to correctly identify and separate those parts. End of the project may not be known which is risk. No one knows end product. We think about small parts, that is one's disadvantage. Highly skilled resources are required for risk analysis. Each stage's risk is very high, because therefore very experienced resource people need for risk analysis part. Risk is very considerable thing in iterative incremental model. Then the prototype model. Third model is about the prototype model. Prototype is the working model of software with some limited functionalities. It is very important. Limited functionalities. The prototype does not analyze all the exact logic used in the actual software applications and is an extra effort to be considered under the effort of simultaneity. Prototype is used to allow the user to evaluate, develop proposals and try them out before implemented. It is also help understand the requirement which are use specific and may not have been considered by the developer during the product design. Here the prototype means actually it's a model. It is not a completed one. It is not the it is not a exact one. It's a model, and that model is taken and developed, adapted to the user requirement. That's why it is that's why it's name given the prototype model. Not the actual the 100% perfect system. It is not. We can adapt our that model into our system. Fourth one, spiral model, and spiral model is another commonly used type in large projects. Spiral model, we can find the 4 basic stages, and using those 4 basic stages, we'll discuss how we use both those 4 basic stages and how to manage develop the software. Before that, I want to explain the 4 basic areas of the spiral model: planning, risk analysis, designing, evaluating. Here, you start with the one part, that means planning. You are starting at here, and risks are identifying, and then design your project, design your part, and evaluate that part, and then you come to the next part, that means planning and risk. Likewise, complete. Finally, you will get the product. While you developing the product, you can have the other parts of the system. That means like it's a little bit similar to the iterative incremental model, not as it is the same the iterative incremental model. These types of products, software development models, this type of models, spiral models were used for very risky projects. We will discuss why it is a very risky type of project. Changing the requirements can be accommodated, and each and every time the product can be changed, requirement can be changed. Then the risk is very high. Therefore, we use this type of model for very risky work. Allow the extensive users prototypes. Requirements can be captured more accurately. Users see the system early. User can see the system. Once you complete your one part, spiral, you will see that part. Development can be delivered into smaller parts, and the risk parts can be developed easily, which help in the better risk management. There is a separate part for in risk identification in this model. Therefore, risky parts you can easily done. How much is the risk on this part, and you can do the risk analysis very easily. Development can be developed, yes. That parts can be developed in easily and help in the better risk management. You can easily manage your risk in this spiral model. Management is more complex. Managing is very difficult in this type of models, and the end of the project may not be known early. We don't know what is the outcome. Either success or fail, we don't know. The outcome is the task. Once you get the output, you have to do that. That's why it is very risky, risk project. These type of projects were models were used in research type of projects. Not suitable for small or low risk projects, and could be extensive for smaller projects. That's why it says not could be suitable for small or low risk projects. This type of model were used for very high risk projects. Process is complex. Very complex process is going in this model. Spiral may go on indefinitely. Your spiral can in here. Your spiral can move up to indefinitely. It is never ending. Once you identify a requirement or plan that and identify the risk and do that, complete it, then after it is never ending. That's why it is incremental requirement. Spiral may go on indefinitely. Large number of intermediate stages require excessive documentation. In this type of projects or this type model, you must maintain your documentation. It is very, very important. Otherwise, you will make you don't know what is your it is saying your final outcome. To take the final outcome is very difficult in this type of model. Once you are not maintain your documents or document maintenance is very important, very important in this type of model. And that for the 4 types of model of the software development models. In last week we discussed about the 6 stages of the system development life cycle, SDLC, and using those 6 stages, how we select which model is better is discussed with this week. I hope you will understand the second chapter, and you will answer the questions for the second chapter. And thank you, and God bless you.